Hello everyone. Today I'm going to explain 5 technical questions from the CCNA. Let's look at the first question. The diagram for this one is too long, so I won't include it here. Let's take a look at this question. It's actually quite simple. It asks us what is preventing the OSPF neighbor relationship from being established between these two routers. So the reason that is preventing the neighbor relationship from being established, let's look for the reason in the diagram is that the MTU value on router 21 has been changed to 1006, right? That is, their MTU sizes are different. The default MTU value, before we make any changes, is 1005. So here, it was changed to 1006. But on the other side, it wasn't changed. That's why the two can't establish a neighbor relationship. This is the main reason. So the correct answer is C. Choose C. Alright, question 2. Question 2 is, it says that when we access a target from 2.1, which router in the routing table will be matched to reach this target? This is another question about subnetting. Let's take a look at subnetting. First, let's look at this 18-bit route. There's a 18-bit route here, though it's a bit unclear, 10.56.120.0 with an 18-bit mask. Now, for this route, it covers from 128. Tokens, it's 18 bits. The 120 part ranges from 128 to 191. This is 128, right? From 128 to 191, so it doesn't match, right? It doesn't match. What is our target value? It's 192. So since this only goes up to 191, it doesn't match, right? So let's look at this 17-bit one. Actually, this one matches even less. The one above, the 17-bit root, starts from 0, and its range is from 10.56.0.0 to 10.56.127.255, which also doesn't match, right? It doesn't match either. So this one doesn't count either. Now let's look at the last two remaining ones. The two 32-bit host routes. These two 32-bit host routes also don't match, right? So which one should we match then? We match this default route. So its next hop is 10.56, 10.56.0.1. So if we carefully apply this particular principle to the available answer choices, we should indeed pick option D, right? The default route is the one that precisely matches actually. Upon closer inspection, it's not D at all. That's a significant mistake. The truly correct answer after thorough consideration is actually option A. Let's meticulously check the absolutely correct answer. It is definitively A. Alright, let's move on to question number 3. Question 3 is pretty similar to question 2, except the value is different. The route value we need to match is different. We need to match this route here. This question is actually testing subnet masks specifically. We need to match the route with the longest mask, which is this one with a 29-bit mask. So which one is it? Let me take a look. It's this one, 184. This one, 72.168.1.184. This is a network address with a 29-bit mask, and it includes 172.168.1.190, right? Because its usable range is from 184 to 191. So this value includes 190. Therefore, we match this next hop, which is 192.168.7.35. So the correct answer to this question is C. Alright, let's move on to the next inquiry. We've covered the previous point thoroughly, and now it's time to delve into the subsequent question that awaits our attention. This question is a bit simpler. It asks what is the advantage of VRRP? The advantage is quite obvious. It's something fixed. A theoretical parameter. It provides a default route, a default gateway. And for whom does it provide it? It provides the redundancy function of a default gateway for the LAN network. So The correct answer to this question is A. Choose A. Alright, question 5. For question 5, there is actually a diagram, but it's also very simple. This question is quite straightforward. Let's look at what it says. This is router 1, and here is 2 to 1, then this one is 2 to 2, and this one is 2 to 3. Between 1 and 3, a default route is used with default configuration. Then, between 2 and 3, the priority of interface 2 is 99. So, how exactly do we go about making this particular item, or perhaps this specific entity, transform and ultimately become the second one in a sequence or series? How do we make this number 3 become the second one? That's how I understand what it means. Which network do we want to make 3 the second for? To make it the second in the whole networking this domain, there's a switch in between. Here's a switch, and everyone is connected to this switch. So what we're trying to express, is how do we make routers 2 and 3 become the second designated routers? So the correct answer is this one. Go to the 0/1 interface of routers 2 and 3, and set the OSPF priority on this interface to 100. Why set it to 100? It doesn't mention the left side, the 2/1 interface, so that means it's using the default value of 1. The interface on router 2 is specifically set to 99. So as long as we set it higher than 99, that's enough, right? So the correct answer is D. Alright, submit. If you want to learn Cisco technologies or get access to Cisco question banks, feel free to message me privately or leave a comment below the video for technical discussions.